Dear students, in this video, I'll explain you some more problems on D'Alembert ratio test. The test says the infinite series sigma un is convergent if limit of un plus 1 divided by un as n tends to infinity is equal to L, a finite quantity. If L less than 1, then sigma un is convergent series. If L greater than 1, sigma un is divergent series, and if L is equal to 1, then the test fails. Okay, there is a D'Alembert ratio test. We are finding the limit of un plus 1 divided by un, that is the ratio as n tends to infinity. Hence it is D'Alembert ratio test. First problem. Test for convergence of the series 1 plus 2 square by 2 factorial plus 3 square divided by 3 factorial plus 4 square divided by 4 factorial plus dot dot. First we need to write down the nth term. Here un is equal to n square divided by n factorial. The first term can be written as 1 square divided by 1 factorial. Nothing but 1 square, 2 square, 3 square, 4 square means n square. 1 factorial, 2 factorial, 3 factorial, 4 factorial means divided by n factorial. Okay, un plus 1 is obtained just by replacing n by n plus 1 it is. Hence, un plus 1 is equal to n plus 1 whole square divided by n plus 1 factorial. Consider limit of un plus 1 divided by un as n tends to infinity. That is equal to limit as n tends to infinity. Un plus 1 is n plus 1 whole square divided by n plus 1 factorial divided by, I make it as into, so we need to write down the reciprocal of un, that is n factorial divided by n square. In n plus 1 whole square, okay, I have taken n outside, okay, outside the square means it becomes n square into 1 plus 1 by n whole thing square divided by n plus 1 factorial can be written as n plus 1 into n factorial into n factorial divided by n square I have written as it is. N factorial as well as n square gets cancelled. That is equal to limit as n tends to infinity 1 plus 1 by n whole square divided by n plus 1 is there. In that n plus 1 once again have taken n outside, n into 1 plus 1 by n. That is equal to limit as n tends to infinity 1 by n is one function I considered into limit as n tends to infinity remaining as another function 1 plus 1 by n whole square divided by 1 plus 1 by n. If we apply the limit as n tends to infinity 1 by infinity, the term is 0 plus, sorry, not plus, into, for this term if I apply the limit, its limiting value is 1 it is. 1 into 0 is equal to 0. 0 is less than 1. Hence by D'Alembert ratio test, sigma un is convergent series. Next one is test for convergence of the series 1 factorial into 2 divided by 1 plus 2 factorial into 4 divided by 4 plus 3 factorial into 8 divided by 27 plus dot dot. Okay. First we need to write down the nth term un. That is equal to, look at this, 1 factorial, 2 factorial, 3 factorial means it is n factorial. Here 2 power 1, 4 nothing but 2 square. Okay, 8 is nothing but 2 power 3 means 2 to the power of n divided by 1, 4, 27. Okay, 1 power 1. Okay, 4 is nothing but 2 square. 27 is nothing but 3 power 3 means n to the power of n. That is a un. Carefully you need to observe the terms and write down the nth term. Now un plus 1, that is equal to n plus 1 factorial into 2 to the power of n plus 1 divided by n plus 1 to the power of n plus 1. Apply the limit as n tends to infinity for un plus 1 divided by un. That is equal to limit as n tends to infinity. Un plus 1 is n plus 1 factorial into 2 to the power of n plus 1 divided by n plus 1 to the power of n plus 1 into, okay, write down the reciprocal of the un. N power n divided by n factorial into 2 power n. Okay. Here 2 power n gets cancelled, only 2 remains. Okay, and n plus 1 factorial can be written as n plus 1 into n factorial. Okay, or I split it 2 power n plus 1 as 2 power n into 2 divided by, in this one n have taken outside. Okay, n power n plus 1 into 1 plus 1 by n power n plus 1 into this term as it is, n power n divided by n factorial into 2 power n. N power n gets cancelled, n factorial cancelled, 2 power n cancelled. What remains is limit as n tends to infinity, n plus 1. In that just have taken n outside, remaining is n into 1 plus 1 by n, and in the numerator 2 is there, 2 divided by, okay, here n power n divided by n to the power of n plus 1 is there, n power n cancelled means n power 1 remains, that n here into 1 plus 1 by n power n plus 1. n gets cancelled. Here also one term gets cancelled, only the 1 divided by 1 plus 1 by n is there, or else directly apply the limit as n tends to infinity. Okay, 2 in the numerator, and this is 1 plus 1 by n power n into 1 plus 1 by n power 1. Okay, 1 plus 1 by n power n, it is e into 1 it is. Okay, 2 divided by e, 2 by e is less than 1 it is, because e value 2.7 something, 2 divided by approximately equal to 3, 2 by 3 definitely less than 1 it is. Hence by D'Alembert ratio test, sigma un is convergent series. Next one, find the nature of the series 2 by 3 plus 2 into 3 divided by 3 into 5 plus 2 into 3 into 4 divided by 3 into 5 into 7 plus dot dot. Okay, what will be the nth term here is, look at this, the terms, number of terms goes on increases in each term. Okay, successively it is increasing. 2 first term is, second term in the numerator it is 2 into 3, in the next term it is 2 into 3 into 4. Okay, then what will be the nth term means 2 into 3 into 4 dot dot up to n plus 1 it is. Okay, that is because 2, 3, 4 that will be in AP. Okay, by using the nth term of the arithmetic progression Tn is equal to a plus n minus 1 into d. If you calculate with the first term is equal to 2 and common difference is equal to 1, you are getting the last term as n plus 1. In the denominator also 3 into 5, 3 into 5 into 7 dot dot dot. It is also AP. So what is its nth term means? Okay, first term a is equal to 3, common difference is 5 minus 3 is 2. Tn is equal to a plus n minus 1 into d. 3 plus, okay, n minus 1 into 2, 2n minus 2. 3 minus 2 is 1, 2n plus 1 it is. I hope you followed. Okay, un plus 1 is 2 into 3 into 4 into dot dot n plus 1 into next term will be the n plus 2. And in the denominator 3 into 5 into 7 up to 2n plus 1. If I replace n by n plus 1 here, 2n plus 2 plus 1, 2n plus 3 it is. Limit as n tends to infinity, un plus 1 divided by un. Un plus 1, write that as it is. For un, okay, write the reciprocal because divided by I have written it as into. And this term get up to 2n plus 1 gets cancelled, and in the numerator up to n plus 1 gets cancelled with the denominator term. What remains is only n plus 2 divided by 2n plus 3. Limit as n tends to infinity. In the numerator take n outside as well as in denominator also take n outside. Okay, after taking n outside that n gets cancelled. If you apply the limit as n, answer is 1 by 2. 1 by 2 definitely less than 1. Hence by D'Alembert ratio test, sigma un is convergent. Next problem, exactly similar to the previous problem. Test for convergence of the series 4 by 3 plus 4 into 7 divided by 3 into 5 plus 4 into 7 into 10 divided by 3 into 5 into 7 plus dot dot. Here un is 4 into 7 into 10 into once again it is also AP. With the first term A is equal to 4. Common difference 7 minus 4 is equal to 3. Okay. Nth term will be Tn is equal to A plus n minus 1 into D. 4 plus n minus 1 into 3. Okay. 3n minus 3 plus 4 nothing but 3n plus 1. As well as in the denominator also same thing it is. 3 into 5 into 7 up to 2n plus 1. Un plus 1 is 4 into 7 into 10 dot 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 3n plus 1 into 3 into n plus 1 plus 1. Nothing but 3n plus 4. Okay, don't write 3n plus 2 it is. We need to replace n by n plus 1. Carefully you need to write. And in the denominator 3 into 5 into 7 up to 2n plus 1 into 2n plus 3. Next term will be 2n plus 3 it is. Limit as n tends to infinity un plus 1 divided by un. Un write as it is and un take the reciprocal because divided by we have written it as into. Okay, what remains after cancelling the numerator and denominator terms is 3n plus 4 divided by 2n plus 3. Okay, take n outside both in numerator and denominator and after applying the limit as n tends to infinity, the answer is 3 by 2. 3 by 2 is equal to 1.5, definitely greater than 1. Hence, by D'Alembert ratio test, sigma un is divergent series. Next problem, test for convergence of the series 1 plus 2 factorial divided by 2 square plus 3 factorial divided by 3 square plus 4 factorial divided by 4 square plus dot dot. Okay, this is the December 19, January 20 question paper problem it is. Okay, here un is, look at this, first term can be written as n 1 factorial divided by 1, hence it is n factorial divided by 1 square, 2 square, 3 square, 4 square, nothing but n square. Un plus 1 is equal to n plus 1 factorial divided by n plus 1 whole square. Limit as n tends to infinity un plus 1 divided by un. That is equal to limit as n tends to infinity un plus 1, that term write as it is n plus 1 factorial divided by n plus 1 whole square. Divided by un, divided by we make it as into and take the reciprocal of the un term it is n square divided by n factorial. That is equal to limit as n tends to infinity n plus 1 factorial can be written as n plus 1 into n factorial and into n square as it is, and in the denominator take n outside. Outside the square means n square into 1 plus 1 by n whole square into n factorial. N factorial cancelled, n square cancelled. Limit as n tends to infinity. Okay, and here n plus 1 divided by 1 plus 1 by n whole square is there. Take n outside, n into 1 plus 1 by n divided by 1 plus 1 by n whole square. One term gets cancelled. Limit as n tends to infinity, n divided by 1 plus 1 by n remains. Okay, because as n tends to infinity, this term 1 by infinity is 0. 1 plus 0 is 1. Infinity divided by 1, nothing but infinity. Definitely it is greater than 1. Hence, by D'Alembert's ratio test, sigma un is divergent series. Next one, discuss the convergence of the series 1 plus 2 factorial divided by 2 square plus 3 factorial divided by 3 cube plus 4 factorial divided by 4 power 4 plus dot dot dot. I hope already I explained this problem. Un is equal to 1 factorial divided by 1 power 1, we can write it as, okay, 1 factorial, 2 factorial, 3 factorial, 4 factorial in the numerator means n factorial. Denominator term is n power n. Un plus 1 is n plus 1 factorial divided by n plus 1 power n plus 1. I hope already I explained this problem. It is right. Discuss the nature of next one. Discuss the nature of the series x divided by 1 into 2 plus x square divided by 3 into 4 plus x cube divided by 3 into 4 plus dot dot dot. This is the June-July 2019 question paper problem. Okay. Here un is x power 1, x square, x cube means x power n. Denominator 1 into 2, 3 into 4. Okay. Actually next term is 4 into 5 it is. Right. Okay. By mistake it is 3 into 4 is there, but it is 4 into 5. First term 1, 3, 4 means that is n it is. Okay. Next term is n plus 1 it is. N into n plus 1 it is. Okay. Un plus 1 is x to the power of n plus 1 divided by n plus 1 into n plus 1 plus 1, nothing but n plus 2. Limit as n tends to infinity, un plus 1 divided by un, that is equal to limit as n tends to infinity, x to the power of n plus 1 divided by n plus 1 into n plus 2 into, okay, n into n plus 1 divided by x power n. Okay, x power n gets cancelled, only x power 1, x remains. N plus 1 cancelled, n divided by n plus 2. Now, limit as n tends to infinity, n into x divided by n, if you take that outside, n into 1 plus 2 by n, n gets cancelled. Apply the limit as n tends to infinity. 2 by infinity is 0, 0 plus 1 is 1, x divided by 1 is x. Hence, by D'Alembert ratio test, sigma un is convergent if x less than 1, divergent if x greater than 1, and the test fails if x is equal to 1. Next one. Discuss the nature of the series 1 divided by 2 into root 1 plus x square divided by 3 into root 2 plus x to the power 4 divided by 4 into root 3 plus dot dot dot. X is greater than 0. Look at that. X power no term of x in the first term means x power 0 is there. Okay. So n is equal to 1 to infinity we are writing. Hence we'll leave the first term. On leaving the first term, un is equal to x square, x to the power of 4 dot 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 means x to the power of 2n divided by 3 into root 10. Okay. 3 can be written as n plus 2. Root 2 square root of n plus 1. 3 into root 2, 4 into root 3. 3, 4, 5 means n plus 2. Okay. Root 2, root 3, root 4 means root of n plus 1. Now, un plus 1 is equal to x to the power of 2 into n plus 1 divided by n plus 1 plus 2, n plus 3, root of n plus 1 plus 1 means n plus 2 it is. X to the power of 2n plus 2 divided by n plus 3 into square root of n plus 2, that is un plus 1. Limit as n tends to infinity, un plus 1 divided by un, that's equal to limit as n tends to infinity, x to the power of 2n plus 2 divided by n plus 3 into 2 square root of n plus 2 into, okay, reciprocal of un term, that is n plus 2 into root of n plus 1 divided by x to the power of 2n. X power 2n divided by x power 2n gets cancelled, x square remains. N plus 2 into root of n plus 1 divided by n plus 3 into 2 root of n plus 2. Take n outside in all the terms it is x square into n into 1 plus 2 by n into root n into 1 plus square root of 1 plus 1 by n divided by n into 1 plus 3 by n into root n into square root of 1 plus 2 by n. Root n, n gets cancelled. After applying the limit as n tends to infinity, okay, the answer comes out as x square. Hence, by D'Alembert ratio test, sigma un is convergent if x square is less than 1, divergent if x square greater than 1, and the test fails if x is equal to 1. 1 One more problem. Okay. Test for convergence or divergence of the series sigma n is equal to 1 to infinity n square divided by 3 to the power of n. Here directly we can write the nth term. Okay, un is equal to n square divided by 3 power n. Un plus 1 is equal to n plus 1 whole square divided by 3 to the power of n plus 1. Consider limit as n tends to infinity un plus 1 divided by un. Limit as n tends to infinity un plus 1 is n plus 1 whole square divided by 3 to the power of n plus 1 into un is 3 power n square divided by 3 power n, because we written divided by s into take the reciprocal of the un term, it is 3 power n divided by n square. 3 power n cancelled. Okay, and n plus 1 whole square divided by 3 into n square. Limit as n tends to infinity, take n outside in the numerator, n square into 1 plus 1 by n whole square divided by 3 n square. N square cancelled. After applying the limit, the answer will be 1 by 3. 1 by 3 no doubt less than 1. Hence by D'Alembert ratio test, sigma un is convergent series. One more problem. Discuss the convergence of the series sigma n is equal to 1 to infinity n factorial divided by n power n whole square. Okay. Here nth term is n factorial divided by n power n whole square. And un plus 1 is n plus 1 factorial divided by n plus 1 power n plus 1 whole square. Limit as n tends to infinity un plus 1 divided by un. Limit as n tends to infinity un plus 1 is n plus 1 factorial divided by n plus 1 power n plus 1 whole square into n power n whole square divided by n factorial. Okay, n plus 1 factorial can be written as n plus 1 into n factorial into n to the power of 2n divided by n plus 1 to the power of 2n plus 2 into n factorial. N factorial cancelled. Okay, here n plus 1 divided by n plus 1 power 2n plus 2 is there. One term gets cancelled. Remaining is limit as n tends to infinity n to the power of 2n divided by n plus 1 to the power of 2n plus 1. Okay, limit as n tends to infinity, spread this as n to the power of 2n divided by n plus 1 power 2, n plus 1 to the power of 2n into 1 divided by n plus 1. N power 2n divided by n to the power of 2n into 1 plus 1 by n whole power 2n into 1 over n plus 1 as it is. N power 2n gets cancelled. That's equal to limit as n tends to infinity 1 divided by 1 plus 1 by n whole power n whole square, because this is the standard limit it is. 1 plus 1 by n power n, limit as n tends to infinity is e it is. 1 by e square into, here if I apply the limit 1 by infinity plus 1. Infinity plus 1 is infinity. 1 by infinity is 0. 0 into 1 by e square is 0. 0 is less than 1. Hence by D'Alembert ratio test, sigma un is convergent. I hope you understand D'Alembert ratio test. Okay. In the next video, we'll see next type of problems.